Hi everyone, today we're talking about animation and we're going to implement animations from scratch, as it were, from first principles. And for that I'm not going to use FXGL or JavaFX for that matter. We're going to use JavaFX to just render things, not animate them. So when you think about animations, the first thing that comes to mind is usually some kind of an object being moved, translated, rotated, and so on. But actually, if you think beyond concrete representations, then animation is quite an abstract concept. It's a change. It's a change in value over time. So to animate something, all you need is starting point, ending or end point, and the duration of the animation. You can animate integers, doubles, floats, any primitives, as well as things like custom classes, strings. You can animate anything as long as you have these three things. So we're going to do just that. First of all, we're going to create a custom class called animated point. We're going to use that to just move one point. We're going to render it so that you have some visual representation of it. Then we're going to add animations to a bunch of points, and finally we'll talk about interpolators. Right, so first of all I need concept of an animated point. It's a 2D point, so things like start, end are going to be 2D points in two-dimensional spaces. We need current x, we need current y, so that we can then draw the point. We will need the duration as well, the duration in seconds. Now I'll let IDE generate the constructor for me, include these three things, because initial x is essentially start x, right? And then duration is going to be a duration from JavaFX util duration. So we're going to use this as an object to pass, and then we're just going to take the seconds as a double value. And that is pretty much everything you need. To animate it, we do need to keep track of current time as well. So we're going to add another double here. And that is going to be updated over time. Now we're going to run this using animation timer, which runs at 60 frames per second, at least on my platform. So that's more or less going to be something like this. Technically speaking, this is 1/60, but this approximation is absolutely fine for now. So how do we then represent the current value? So if you've done any kind of maths or physics, then you might think, well, we need to figure out the value, the sort of delta value, the change value over time. But interestingly, there is a different way of doing this, because when it comes to animations, you can compute each value given the time ratio. And that's great because we don't need to worry about things like velocity or acceleration. So what we can do is obtain the ratio of time, which would be current time over the maximum amount of time. The maximum amount of time being the duration. And this gives us the ratio of time, which is always going to be between 0 and 1, because as t grows, it's going to reach this value at some point, and then we're just going to stop. So if t is greater or equal to duration seconds, then t is 1. So we're kind of forcing it to be 1. And obviously it starts at 0, so that should be fine. Now that we have this ratio between 0 and 1, we can convert that to progress. Suppose we have an animation that starts at, I don't know, 0 and goes to 200, right? At t ratio 0, it's going to be 0 because we've just started. At t ratio 1, it's going to be 200 because we just finished the animation. Anywhere in between, t ratio is going to map directly to one of these values. Now, it's quite intuitive to figure out the middle point, for example, which is going to be 100, because 100 is the middle value between 0 and 200. So at t ratio 0.5, which represents 50%, it's going to be right in the middle. So this is t ratio, and this is the actual value. 0.5, and then something like this. So you can see that there is a direct mapping between t ratio, which is essentially progress, and the value that we're animating. In which case the value, or I suppose x, is... So how do we obtain x from all of this? This is start, this is end, and we're given t ratio. You could say, well, how do we get from 200 to 100 given 0.5? Well, we'll multiply by it, right? 200 multiplied by 0.5 gives us 100. So t ratio multiplied by and get x. Will that work? In this specific case, yes, because we start at 0. Now, if we started at something else, like 100, let's do another. So this is value 2, right? We start at 100, we move something, we don't know what that value is, and we end up at 200. Now, if we follow the same logic again, we multiply t ratio, which is 0.5 for this one. We'll multiply it by and get x, which is 200. We get 100 again. But this is not correct because intuitively, we know that this has to be 150. That's the middle value between 100 and 200. So how do we get to 150? I'll leave the exercise up to you to kind of derive this information, but I will give you the answer straight away for sake of simplicity. So what we do is we take the end value, we subtract the start value from it, we get 100. We multiply 100 by the t ratio, which gives us 50, because we multiply 100 by 0.5, which is going to halve it, and we add the 50 to the starting point, which gives us 150. And we do the same for y. Right, now that we have x and y, shall we just try it? In order to try it, I actually need to build something, because so far we only have the abstract concept that we talked about. So we need some JavaFX application to go with it. Just going to build a very simple application that's going to contain pretty much the only thing, canvas, I guess. Main, parent. So shall we say, well, it doesn't actually matter what the root node is. Right, we've got ourselves a canvas. We need something to draw on, graphics context. We need an animation timer. Start the timer. And then on that timer, we're just going to call onUpdate, which is where all the fun stuff will happen. Right, we need a list of our animated points. I'm making it into a list because we're going to add more points. For now, it's going to just be a single point. Create content. Let's add a point here. New animated point. Start is going to be 100, 100, and there's going to be 200, 100. So it's going to move horizontally. And duration is going to be 3 seconds. And then what we do on update is we're going to go through each point. We're going to update that point, and then we're going to render it. Set draw, stroke, fill. There we go. PX, PY, and then we need size, right? Let's make our points big-ish. And then we need to do something like this here. Because it's going to draw from top left, and because a point is essentially a circle, I want to slightly reposition it so it draws from the center. We need to set some colors. Fill rectangle. So I'm going to draw a black rectangle first, and then the points are going to be white. Is that everything? I think so. Now, this is not going to work. It's the T ratio that I need to update, right? So if T ratio goes over 1, then T ratio has to be 1, because you can't animate beyond 100%. Doesn't make sense. Let's run and see. Oh, I didn't actually start animation, sorry, JavaFX platform. So our main actually doesn't do anything. Let's call launch, and it should now do something. Shall we make it a bit bigger? Because it's there, it's moving. Let's make it something like 8 pixels. So here it is. It's a basic animation that we achieved using more or less first principles of what animation really is. Now, let's animate a bunch of points. Since we already have everything in place, what we need to do is just populate this list, populate with points. You could extract this into a separate method, but I'll do it here. So we don't need this thing anymore. What I'm thinking is, how about we create a bunch of points on the circumference of a circle and then have them move towards an inner circle. So it's going to be an interesting looking animation. At least it's interesting looking in my head. We'll see how it actually looks physically. So to place things on a circle, what you do is just create a vector for each angle of the circle, because it goes from 0 to 360, and then using these vectors you can populate the points. But before we do that, let's just very briefly recap, because this is ending the first sort of bit about what animation really is. Animation is a change of value over time. We have the start point, the end point, and the duration. Everything else is just kind of implementation details. But these three things, which are very nicely highlighted by the IDE actually, are the things that we need for an animation to happen. Everything else is just kind of concrete implementation details, which may vary from how you want to represent your animation. And now let's move on to the next bit. So how many degrees are there in a circle? 360. We'll go from 0 to 360. But I don't want just 360 points. I want more points. We need points, lots of points. We need, let's go for something like 3,600 points. Should be fine. Num points. We're going to create a point, and we're going to place it on the circumference. So we need to figure out how many degrees we need to allocate per point. Degrees per point, which is num points divided by 360. So I've picked 3,600 deliberately because it is divisible by 360. And this is the number of degrees that we... Is it the other way around? Yeah, it's the other way around. Because we can only have so many degrees in a circle. And make sure it's a double, because otherwise you're going to get integer rounding errors. You won't actually get any meaningful degrees out of it. So this is how many degrees we're going to rotate for the next point, like in a circle. And so we need to obtain an angle first, which is degrees per point multiplied by I. I is the index, and then when I is the last number, it's going to be 360, which is good. Now, how do I convert an angle to a vector? Because remember, we still need to identify a two-dimensional point where we're going to place our circle, which just happens to be on the circumference of a circle. To do that, you can obtain the angle, and then from the angle you need the vector, and then from the vector you need to get the center point of a circle so that you can add the vector to the center point. So we need to do a few things. First, we need a vector. Vx, luckily it's just cosine, and the other one is sine, so we don't need to do too much. This is angle in degrees, so I need to convert them to radians. Vy is sine. It's all kind of geometry related and all that kind of stuff. I normally say to students that you don't need maths in game development, or you don't need a lot of maths. But having a good foundation in maths really, really helps. It just makes a lot of stuff so much easier to understand. So we've got the vectors, and now what we need is the center point. Center point is easy because I'm going to use 400 and 300, sort of the middle of the window. So my center point is super easy. Vx, Vy are the vectors. Remember, cosine and sine return a value between -1 and 1. So these are not going to be very long vectors. They're indeed very short. So how we are going to extend them, we're going to scale them. We're going to multiply by the same value to extend our vectors. And that will be something like 150. We can finally add the Vx and Vy to our center point to obtain our starting point. I just realized that this video is getting slightly more complicated than I initially intended, so sorry about that. The end, so I want to have points on a kind of larger circle and then have them animate towards the middle, so the smaller circle. So what I can use is the same vector, but scale it differently. So I can just use this and then maybe multiply by 0.5, 0.25. We've got the 2 points. Now all we need is just duration. I'm going to do this for every single point that we create. That's start and end. That's simple. Duration 3 seconds. Yeah, that'll do. Let's see this in action. Provided that we've done everything correctly, should be, yeah, that's what I had in my head, more or less. So what we've created is, it's almost like a shrinking circle, but we now know that it's not a circle, it's a plethora of points around the circle. Which all move at the same time. But animation is best when it's used with things like delays and interpolations, but interpolations, we'll get to those. So with delays, we can manipulate this thing, because you can see that it's 3 seconds for every point that we create. Now, if we change it from 3 plus and then use this as a seed for something, I multiplied by some small value. So what's the largest I? It's 3,600. So multiplied by this gives us 3.6 seconds. I'm just trying to calculate how long it will take for the last point to animate. That gives us, I think, in total 6.6 seconds. The very first one being, this is 0, so that's 0, so 3 seconds. So you should see now an slightly more fancy animation. Yeah, just a little bit more different. But they all start at the same time. So if you wanted to go further, add a delay here, which doesn't start the animation until that delay has completed. And if you don't want to implement all of that from scratch, just use FXGL. It's got everything you need. Or indeed JavaFX, it also has some of these things for animations. Now, one last thing is interpolation. I'm not going to go too far with that, but I will give you the basic concept behind it. So remember how we said t ratio is basically progress? Now let's just write it down. Progress t ratio, and then use this value instead. So technically speaking, I haven't changed anything. I just rewrote it. And now we're going to make something interesting. Interpolate t ratio. Again, I haven't changed much. It's going to result in exactly the same animation because it returns the same thing. But if you write it this way, it's much clearer now that progress could be a result of a function of t ratio. So if you change t ratio to progress mapping, then that mapping represents the interpolation. You're changing the rate of the animation. As long as the return value is between 0 and 1, you're good. We know that this is going to be between 0 and 1 because we said so. We managed that. The result could be interesting. So if you do something like this, this is what? This is quartic, quadratic, cubic, quartic. Yep. And then if you want to go further, that's quintic, raised to the power of 5. Now if you do this, the animation is going to start and end at the same time, but the values are going to move differently. So you can see that this is a completely different animation visually. It runs for the same length because t ratio didn't change, and it also starts and ends with the same values. The only thing we've changed was the rate of the animation, as in how fast it starts or how quickly it ends, with overall duration being exactly the same. And you can really play with this. Like, you can change this to something like this. Does this give us the same range? If this is 0, this is 1. If this is 1, this is 0. And anything in between is fine. So this, in theory, should flip the animation, actually. There we go. So by just changing the interpolation function, we've also changed what? We've inverted the animation effectively. And there are lots of interpolates to play with. FXGL's got built-in ones if you want to use those, or just Google how to interpolate. These are also called easing functions or tweening functions, depending on what kind of background you're coming from. In web development, they're called something different. I think easing. Anyway, that should be reasonably good for starters, so that you can do your own research after that. But this is what animation really is. It's just an abstract concept that you can visualize concretely using different means. On that note, thanks for watching, and I'll see you in the next video.